Hello everybody, welcome back. Today we're going to finish up Chapter 10 with Lesson 10.7, Areas of Circles and Sectors. Okay, objective to find the area of circles, sectors. We're actually going to skip the segments part. Okay, so finding areas of circles and sectors of circles. And first thing we're going to start off with is just the formula for an area of a circle. Okay, remind you what that is. You've seen that before. Okay, A equals pi r squared. In other words, the area equals pi times the radius squared. Pretty simple formula to use. Plug the radius in, you get the area. And since we've already seen this formula in years past, let's just jump right into some applied problems. You'll get some easy ones and the hard ones in the homework. We'll jump right into the hard ones. Okay, problem 1 says the radius of the bullseye on a dartboard is 4 inches. Each additional ring on the dartboard is 4 inches wide. What's the area of the shaded region? Okay, so in other words, what's the area of this shaded donut shape we see in the middle of this dartboard? Okay, now I didn't give you an area formula for a donut shape, but what I can do is basically if I find the area of this middle circle, okay, coming to the edge of the shaded region, and subtract the area of the white circle in the middle, what I'll be left with is this shaded spot. Okay, so let's fill in this picture with what we know. It says the radius of the bullseye on the dartboard is 4 inches, meaning that from center to edge of the bullseye is 4 inches. Okay, it also says that each additional ring of the dartboard is 4 inches wide, meaning that a ring kind of from the outer to the intersection of is at 4, and we know we have another 4 for the radius of the bullseye, which gives us a radius of this kind of middle circle of 4 plus 4, in other words, 8. Okay, like I said then, to calculate the area of that shaded donut shape, we're going to say that the shaded is equal to, we'll say, the middle region minus the, we'll call it inner region. Okay, for the middle, we're going to calculate the area using that 8 as a radius. So we can just say pi times 8 squared. Area of a circle is just pi r squared. Okay, minus area of the inner region, which would just be pi times its radius, 4 squared. All right, I'm going to use a trick we've used before. I'm going to keep the area in terms of pi just to make calculations easier. 8 squared is 64, so I'm just going to call this first part 64 pi. Okay, I'm going to leave the pi out of my calculator. I'm just going to calculate the 8 squared. Okay, minus 4 squared is 16, so we'll call this part 16 pi. And the reason I did that is it's just going to make calculations easier. Okay, it's really easy to go 64 minus 16, which would give me a 48. So I can say this area is 48 pi. It's a pain in the butt to plug both of these in, get rounded as approximations, plug those messy answers back in. Okay, life's easier when we leave it in terms of pi. Okay, so now MathXL might ask for answers in terms of pi like this, or it might say round it. Okay, this one doesn't specify, that's why we're doing both. Okay, if it says do round to a decimal place or whatever, that's where you'd actually go 48 times pi on the calculator, which would give us a 150 point, we could say 8, and we're talking inches squared for this one. Okay, we'll say that's our answer. Again, pay attention, do we want the answer in terms of pi or not? But along with that, I'd recommend leaving things in terms of pi until you get to the end. It's going to make life easier. All right, so next thing we're going to talk about is a sector of a circle. Okay, what is a sector? A sector is basically like a slice of pizza. It's a slice of the circle. So if we think of this pizza as making a circle, hopefully it's not right before lunchtime for you guys like it is for me, and we take one slice of it, okay, basically that's what a sector is. Okay, a slice of that circle. Now, this is going to be similar to what we did in our last section. In the last section, we looked at finding arc measures and lengths of arcs. Remember, this slice kind of makes an arc on the end, and we looked at finding the arc length. Okay, so kind of the length of the crust in our last section, okay, a chunk of the circumference. What we're going to do with areas of sectors is essentially just find the area of the actual slice. And it's going to be very similar to the way we approached this arc length. So on to the technical definition then. I'm going to say a sector is a region bounded by an arc of the circle and the two radii to the arc's endpoint. Okay, so in other words, if I have an arc along the outer edge of the circle, and I draw the radii from the edge of the arc to the center, that leaves me with my sector. Okay, and then to find the area of the sector, what we're going to do is, like I said, very similar to what we did with finding arc length. Basically, we're going to look at the fraction of the circle, so the arc measure divided by 360. Okay, the degrees that make up that arc divided by the total degrees of the circle. And then instead of multiplying by the circumference of the circle formula, like we did in our last lesson, we'll just multiply by the area formula. Okay, so essentially how we do that is we find the area and take a fraction of that area. Let's take a look at an example. All right, so what's the area of the shaded sector? What's the area of the shaded slice of our circle here? A second ago, we just said that it is the measure of the arc divided by 360 degrees. Okay, that's how much of the circle we're looking at. And then times just the total area, pi r squared. Okay, so for this first problem, our arc measure is just 36. So we'll go 36 over 360. In other words, we're talking about a tenth of the circle here. Okay, times pi times 6 squared. And to calculate this, we'll leave this one in terms of pi. Typically, questions that don't have any context to them, keep it simple, leave it in terms of pi. So what I'll do is I'll plug into my calculator 36 divided by 360 times 6 squared, and that gives me a 3.6. And since we're leaving in terms of pi, we didn't include that in our calculation. We'll just say 3.6 pi, and then there's no units on here, so we'll just say units squared. Okay, why don't you take a minute, pause the video, give part B a shot, and then click play once you're finished to check your answer. Right, let's go through part B here. We need our arc measure, which in this case for the shaded part is 45 plus a 90. Okay, this entire arc will be these two chunks added together, 45 plus 90, that's going to give us 135 degrees. Okay, so my arc measure will be 135, okay, divided by the whole circle, 360. That's how much of the circle we're looking at. And then times pi r squared, so times pi times 2 squared. And again, leaving things in terms of pi, we'll go 135 divided by 360 times the 2 squared, and that gives me a 1.5, so we'll say 1.5 pi units squared. Right, there you go. That's areas of circles and sectors. Okay, not a whole lot to it. Hopefully you're seeing this is pretty similar to stuff we did in the last section. It's not too difficult. So like usual, give the homework a shot and let us know if you get stuck. We're here to help you out.